To achieve thin dihydroxylation of alkene, we need to use reagents different than those used in epoxidations. Two main reagents are used for this purpose. The first one is osmium tetroxide. Osmium is a transition metal, which is quite one of the very expensive metals. And using osmium tetroxide, we can introduce two hydroxy groups directly. The OH groups actually don't come from osmium tetroxide, they come from hydrogen peroxide, so osmium tetroxide is really used only in catalytic amounts. The mechanism for this transformation involves again reaction between osmium tetroxide and an alkene, where first one of these osmium-oxygen double bonds attacks the alkene, it some back attacks and returns electrons to osmium to give us this 5-member transition state. It's not a 5-member transition state, it's a 5-member intermediate, which is then cleaved using hydrogen peroxide to regenerate osmium tetroxide and give us our diol. If we run this in a cyclic system, the reaction proceeds with, well, even in acyclic systems, the reaction proceeds with thin geometry, but in a cyclic system, this gives us a cis diol, which can then, in fairly high yields, about 70%. Okay. This reaction also works with potassium permanganate. This is a different reagent, we can achieve the same purpose. Again, potassium permanganate will give us this conversion in about 50% yield. It's again a cis glycol, but the mechanism is a little, it has a lot of similarities, but it's still a little different because manganese, unlike osmium, is not very expensive, so there's no need to regenerate it. So it's used in stoichiometric amounts, although the mechanism here is quite similar. And so what we end up with is this manganese compound, which is then hydrolyzed. And this is a difference because here we simply use water, not hydrogen peroxide, to give us the cis diol and manganese oxide, which is no longer active. Now these two reagents both achieve the same purpose. The yields in this case are a little lower, but the reagent is cheaper. And so the difference lies in the fact that osmium is catalytic, it's more efficient, and but it's expensive. In cases where we need very high efficiency, we have valuable alkene, we'll use osmium tetroxide. Otherwise, we can use potassium permanganate, which is cheap. We use the stoichiometric amount, but that doesn't matter because it's cheap, and it gives us lower yields. But again, if economics of the oxidation is of value, then potassium permanganate is of value. So this is really a judgment call between these two reagents, which achieve the same transformation. So to sum this up, to get transdiol from an alkene, we would epoxidize and then open that up either nucleophilically or under acid catalyzed conditions with water to give us a transdiol. If we want a cis diol, we have two options. We can use osmium tetroxide followed by hydrogen peroxide or potassium permanganate followed by base. Both will give us cis diol.